Open any AI chatbot and ask it something simple. Watch closely. There is a tiny pause and then the answer pours out, word after word, fast. Now paste in a long document, a 40-page PDF, and ask about that. This time the pause before the first word is noticeably longer, but once it starts, it still streams just as fast. So here are 3 small mysteries you have probably felt without ever naming. Why is the first word always the slowest part? Why does that opening pause grow with how much you paste in, while the speed afterward does not? And why does a really long conversation eventually get slow, get expensive, and sometimes just stop dead? The natural guess is that the model is thinking harder on the big stuff. It is not. Every one of those mysteries is the same story, and it has surprisingly little to do with the AI being smart. It is about memory, how a model holds a conversation in its head, and the strange fact that holding it, not thinking about it, is what fills up the machine. Today we open the hood. The model does 2 completely different jobs on every message, and blurring them together is exactly why this feels mysterious. First, it reads your whole prompt all at once in one big parallel gulp. This step is called prefill, and it is where the heavy lifting happens. The more you paste in, the more there is to read before it can say a single word, and that is your opening pause. The industry even has a name for it, the time to first token. Then it switches to a completely different job. It writes the answer, one word at a time, each new word waiting on the one before it. This step is called decode. And here is the surprising part, the key to the whole episode. Writing each new word is limited not by thinking, but by remembering. By how fast the machine can pull the conversation back out of memory. The math units, the parts that actually do the arithmetic, are mostly sitting idle, waiting. Engineers have a name for this. Decode is memory-bound, starved for memory while the math sits unused. That is why the first word is slow. There is a lot to read, and the rest are fast and steady. It is just streaming from memory. So what is decode actually remembering? Back in Season 1, we saw that to choose each new word, the model looks back at every earlier word. That is attention. Now think about what that would cost if you did it the obvious way. For every single new word, you would reread the entire conversation from scratch. A short chat, fine. But the work piles up faster and faster as the conversation grows, because each new word makes you reread a longer and longer history. That is a quadratic blow-up, and it would make long chats impossibly slow. So the model cheats brilliantly. The very first time it processes a word, it saves that word's attention notes, its keys and its values, and then it reuses them forever. It never rereads that word again. That saved pile of notes is called the KV cache. It is the model's sticky note for the conversation, and it turns rereading into simply remembering. This one trick is what makes long conversations possible at all. Here is the catch, and it is the heart of this whole episode. That sticky note is not free. Every word you add parks more notes in the GPU's precious memory, right alongside the model itself. And with real numbers, it bites hard. Take a long conversation that fills a big context window, around 128,000 tokens, those word pieces from Season 1, running on a large 70 billion parameter model. Holding just that one conversation is roughly 40 gigabytes of cache. 40 gigabytes on top of the model for a single chat. And that is for one person. Now stack up many people chatting at once, each with their own sticky note growing word by word. The wall of notes climbs toward the ceiling of what the GPU can physically hold. And when it hits that ceiling, there is no more room. The conversation that was getting slower and pricier suddenly just stops. That wall is the answer to our third mystery. In a real server, it is almost always this, the cache running out of room, not the raw computing, that decides how many people you can serve at once. The memory, not the math, is the bill and the wall. So if memory is the real limit, how does one GPU serve thousands of people at once? The obvious way is to gather a group, run them together, and start the next group when this one is done. That is called static batching. The problem is that answers are different lengths. Some finish in 5 words, some in 500. So the quick finishers sit there, idle, while everyone waits on the slowest one in the group. You are paying for an expensive machine to stand around. The fix is to stop thinking in fixed groups. With continuous batching, the server rebuilds the batch every single word step. The instant one answer finishes and frees a slot, a waiting request slides right in. The GPU never coasts. That move on its own is worth several times more throughput, and there is a second trick stacked underneath it. Instead of giving each conversation one big messy block of memory, you store the cache in small fixed-size pages, the way an operating system manages memory, so the sticky notes packed together with almost nothing wasted. This one is called PagedAttention. Put paging and continuous batching together, and one well-known benchmark measured over 20 times the throughput of the naive approach. Same GPU, same model, just smarter packing. Notice what did not change. Not a single calculation got faster. The machine simply stopped wasting itself. There is one more piece of waste, and once you see it, you cannot unsee it. Think about how an app actually talks to an AI. It sends the same long system prompt every single time, or the same pasted document over and over with just a new question stuck on the end. By default, the model rereads that whole repeated chunk from scratch on every call, building the exact same notes it built a second ago. Pure waste. So modern servers reuse them. If 2 requests share the same opening, the server computes the notes for that shared part once and hands the same notes to both. This is called prefix caching, and it is switched on by default in the leading serving engines now. The repeated document lights up, already remembered, and only your new question actually gets read. That is often the quiet difference behind a cheaper price tier. But there is one honest catch worth knowing, because it explains a real piece of engineering advice. It only reuses an exact match from the very start of the text. Change a single character near the beginning, and the entire cache downstream of that point is thrown out and rebuilt. Which is why the rule is simply, put the unchanging stuff first and the part that changes last. Now pull all the way back, because every fix in this episode is secretly the same move. Remember from earlier, during decode, the GPU's math units sit mostly idle, starved, waiting on memory to feed them the conversation. That one fact explains everything. Continuous batching fills that idle time with other people's words. Paging shrinks how much has to move through memory. Prefix caching stops moving the same thing twice. Not one of these makes the arithmetic faster. They simply stop the machine from standing around. That is the whole secret of serving an AI. Writing each word is limited by memory, not by thinking, so the entire game is to feed memory smarter, not to crunch harder. And here is the honest frame to carry forward. For a long time, running an open model on your own hardware had a real reputation. It wasted most of the GPU and fell over the moment a few people used it at once. That genuinely was true. But paging and continuous batching largely solved it. It is a knob you tune now, not a law of nature. The next episode plays the other side of this same idea, not feeding memory smarter, but doing genuinely less work per word. So here is your reward. This is a real serving dashboard, the kind providers publish, and a few minutes ago it would have been gibberish. Look again. Time to first token. That is just prefill, the very first thing we learned, how much there was to read before it could speak a word. How fast it streams after that first word. That is decode, bottlenecked by memory, not by brains. Throughput, the total words per second across everyone being served at once. That is how tightly paging and continuous batching are packing the GPU, and that cheaper price tier you noticed. That is often prefix caching, the provider simply not paying to reread the same prompt twice. And the wall, the long chat that slowed down and then just stopped. Now you know it by its real name. You ran out of room for the sticky note, not the model getting tired, the cache hitting the ceiling. An AI's memory is a sticky note. It rewrites every word, and that note, not the math, is what you actually pay for. You are not reading marketing anymore. You are reading the machine.